Today we're going to look at reviewing trigonometry. The learning goals for today's lesson are that we're going to be recalling Pythagoras Theorem, determining unknown side lengths in right-angled triangles using trigonometric functions, and also determining unknown angles in right-angled triangles using trigonometric functions. So, in order to find side lengths, we've got two possible strategies that we can use. We can use Pythagoras Theorem, or we can use trig functions. So Pythagoras Theorem, just as a refresher, is a relationship between the three sides of a right-angled triangle. The longest side is called the hypotenuse, and there are the two shorter sides that are also related in a right-angled triangle. The hypotenuse always occurs directly across from the right angle in the right-angled triangle. The relationship for Pythagoras' theorem is that the hypotenuse squared is equal to the sum of the other two sides squared. So adding them together. Now, in order to solve problems using Pythagoras' theorem, we need to substitute into Pythagoras' theorem and then use algebra to rearrange to find the unknown side that we might be looking to find. The three trigonometric ratios are sine, cosine, and tangent, and they're given these abbreviations, but we still say sine and cosine and tangent when we're using them. Even if you are shortening them, most people would say sine, cos, and tan, even though it's sort of spelt sin. Most people still say sine. So for our trigonometric ratios, these are ratios that are true for any right-angled triangle. And the reason for that is that with any right-angled triangle in the same in varying sizes, if the angles are the same, then those side lengths will have the same ratios. So if you've got a right-angled triangle and then you double the side lengths, all of the side lengths will double, the angles stay the same, and that means that the ratio between the side lengths, so if I take one and divide it by the other, will still stay the same. So this is why the trigonometric ratios work. So when we're looking at the trigonometric ratios, we need to remember that we've got our hypotenuse, which is always opposite the right angle. We've got our opposite side to the angle we care about, and we've got the adjacent side, which means next to. So the side that's next to the angle that we care about. If we were looking at the angle up here, if we were looking at this angle up here, then this side would be the adjacent side, and the other side would be the opposite side. So it depends on which angle that we're looking at as to what the adjacent and opposite sides will be. The trigonometric ratios, or definitions of the trigonometric ratios, are the sine of the angle is equal to the opposite angle divided by the hypotenuse. The cosine of the angle is equal to the adjacent divided by the hypotenuse, so these are these ratios, and the tangent of the angle is equal to the opposite divided by the adjacent side. We can use and try and remember these relationships with SOHCAHTOA. If you can remember SOHCAHTOA, it'll remind you, be a mnemonic reminder of each of the different trig ratios: sine, cosine, and tangent. So to find an unknown length in a right-angled triangle, we need to do a couple of things. We choose the trigonometric ratio that links the known angle and the known side to the unknown side. So if I know the angle that I have, and the known side is the opposite angle and the unknown side is the hypotenuse, the opposite opposite side and the hypotenuse is the sine function. So I would use the sine function to work that question out. So then we substitute into the required formula, so that's the ones above here, and then solve for the unknown side. Let's have a look at some examples now. So first example that I have here is find x in the following right-angled triangles. So the angle I have here is this angle, and it is we have the values that we have. We've got the side length that's opposite it, and we've got the side length that is next to it, that's adjacent. So because we've got opposite and adjacent, we need the tangent the tangent function. So to solve this one, we know tan theta equals opposite over adjacent. We always write the formula. Always write the formula. Then we write tan 69 is going to be equal to the opposite, which is x divided by the adjacent 38. Multiply both sides by 38 and we get that x is equal to 38 times tan 69, and that comes out to 98.99 for our value for x. So it's going to be 98.99 millimeters. Just as a general rule, we'll round to 2 decimal places for most values. For our next one here, B, we've got our angle here. We've got the hypotenuse is what we're trying to find, and the opposite. So because we've got the opposite and we're trying to find the hypotenuse, we need to use the sine function. Opposite over hypotenuse. So the angle that we have, substitute in 33. The opposite side is 21 divided by x. Now we need to multiply both sides by x, and we get x sine 33 equals 21. Divide both sides by sine 33, and we get x equals 21 divided by sine 33. And then we get that that is equal to 38.56. So that side length is going to be 38.56 meters. So remember, we need to solve algebraically as we go down. Complete algebraic steps. Do the same thing to both sides. So multiplying, I firstly multiplied both sides by x, then divided both sides by sine of 33. I'm not shifting anything around, I'm doing the same thing to both sides. Remember those rules from your algebra. Now with finding an angle, our inverse trigonometric functions we can use to determine the angles in a right angled triangle. So we need to remember these relationships, hypotenuse, the opposite angle to the angle that we care about, and the adjacent side to the angle that we care about. And we can use these relationships. These are the inverse trigonometric functions that you find on your calculator by pressing the second button or the shift button, the second button, and then the trigonometric function that you care about. So second and sine will give you sine to the -1, these inverse trigonometric functions. And then we have sine, -1 of opposite over hypotenuse will give us that angle, that relationship. So this is about working out the relationship in reverse. So let's have a look at some examples of how to do this. So firstly, we need to find the value of angle of theta, in the following right angle triangles, and we need to round to 2 decimal places if necessary. So our first one here, we've got our angle, we've got the opposite side, and we've got the hypotenuse. So because we've got the opposite and the hypotenuse, we know that our angle, theta, is going to be equal to sine -1 of the opposite over the hypotenuse. So that's sine to the -1 of the opposite side, 1 over hypotenuse 2. So that means our angle, theta, is going to be 30 degrees there by plugging that into our calculator. Looking at our next triangle now, we've got our adjacent side here and our hypotenuse. Our adjacent side and our hypotenuse. So that means we're going to need to use our cosine function. So theta is going to be equal to inverse of cosine, inverse of our cosine function of our adjacent over hypotenuse. So inverse of cosine function, our adjacent side is 1.5 and our hypotenuse is 2.5. Plugging that into our calculators gets 53.13 degrees, rounded to 2 decimal places. So we need to remember our learning goals for today. We reviewed Pythagoras Theorem. we've looked at being able to find unknown sides using trigonometric functions, and we've been looking at being able to find unknown angles using trigonometric functions as well.